My name is Myoda. I am actually not a doctor or a PhD, and I'm a sculptor. So in sculpture and fine arts, there's an MFA, which is a terminal degree. So I was talking to someone the other day. I was like, he was saying that I use a lot of science and technology. I thought, well, I sort of pretend that I'm an engineer, and sometimes I pretend that I'm a scientist. But then I was wondering, like, what if you do it for a really long time and it actually starts working? Like, it's like you pretend that you know how to speak Chinese and then people start understanding you. Does that mean that you know how to speak Chinese?
Yeah.
But anyway, so I'm very much talking from the perspective of an artist, of a sculptor. And when Eric mentioned this, I was very excited because so much of my thinking about art making and sort of my practice, as well as many of the classes I teach, have to do with sort of intersection of sort of the STEM disciplines, science, technology, engineering, math, and the arts. Actually, out of curiosity, are there people here who are part of that STEM to STEAM club at all? Great, a bunch of you, that's great. Yeah, I mean, that's this totally fascinating thing. And thinking about that, it even makes me wonder, like, why and when do we have those divisions between the disciplines? I mean, they're useful to a degree because there's so much stuff to know. But then again, they often sort of result in unnecessary sort of categories or unnecessary borders, and I guess unnecessary sort of thought processes. So I'm going to talk about that kind of subject, but basically this will be a presentation about my sculptural practice. So I'll talk about a number of different projects. The first slide I wanted to, is this quote from Aristotle. So men have more teeth than females. In the case of men, cheek, twist, and swine. In the case of other animals, observations have yet to be made. The more teeth they have, the more long-lived they are as well. Okay? So Aristotle, this great authority, and they weren't called scientists back then, sort of natural science philosophy, but it was under the umbrella. So then a little bit later, a lot later, there's a great philosopher of science. So Aristotle maintained that women have fewer teeth than men. Although twice married, it never occurred to him to verify the statement by examining his husband. We have the same number of teeth, men and women. So somehow Aristotle didn't count the teeth, but made this sort of extrapolation, this conclusion. So this made me, I think I've heard this quote and this story quite a long time ago, but it sort of stuck with me, thinking like, well, how could he have gotten away with it? And also, it had me thinking like, well, it's so absurd, but maybe back then, it didn't seem that absurd. And maybe it's because we are so much the children of the scientific method, where we make a hypothesis and we observe what's going on. We collect that data and then we confirm the hypotheses. So maybe we're so much children of that method that it never occurred to us not to count, not to look. So then here's another quote that kind of has stuck with me for a while. It's Picasso. So he says, we all know that art is not truth, but art is a lie that makes us realize truth, at least the truth that is given to us to understand. So the artist must know the manner whereby he convince others of the truthfulness of his lies. So he abbreviated this a couple times, but it's often even shorter, so pithy. That is, his art is a lie to reveal the truth. So then this one stuck with me because it just kind of calls into question, well, what is, the truth that he's talking about? What is, is that similar, if not the same, as the truth that scientists are sort of after? And what are those kind of different, if they're the same, what are the different processes so to get there? So I am trying to think about this scientific method. I think we all learned it in school, like grade school even. And when I revisited it, actually this summer, I was thinking about it for some other, for an article I've been working on. Got really almost lost down the rabbit hole. Because I remember it as being a pretty clear thing. Like in school they said, this is a scientific method, it was formalized by Bacon, and there's this number of steps. But when I started looking into it, it became way more confused than that. And I think logically, or even, I don't know, yeah, logically, it is absurd to think that this would be the way that all scientific truths are done. So to kind of recap, and this is an sort of an encapsulation of a number of different methods that I found in my research, because there's a lot of different kind of ways to cut this up. So it begins with the research part, the ask a question part. So again, this is definitely chicken egg, because we're in school, we research, we learn stuff. There's sometimes we can ask questions that are already known, it's easy to find out. Then at a certain point in our education, at a certain point, sort of when we know certain things, then those questions are the ones that haven't been asked before. And that's what you try to do. You try to find those exciting questions which weren't asked. So there's where, especially if you think about kind of back to Aristotle, there's been a lot of time, a lot of people asking really interesting questions. So is it the case that there's fewer questions? I mean, it seems to me that there's many more questions because of this method. So the next one would be create a hypothesis. So the hypothesis is another name for it, I think, is a guess, right? But an educated guess. Like, oh, well, I had a question about something in the world, and maybe it is the way it is because of this reason. That's my guess. So what do you do to try to figure it out? What do you do to try to prove it? Well, then comes the next step, which is to experiment and to compile the data, right? So here's where I'm going to say that when I'm thinking about the scientific method, when I'm thinking about this, just the process, I'm thinking, wow, this is identical to what it means to make art. Because in art, I have done a lot of research about art, I have education in art, and if I ask a question, I make sure that it hasn't really been asked before in the way that I'm doing it. And then I say, well, maybe this would make interesting art if I pursued this. And then instead of experiment, we can call it experiment, that would be sort of making art, like making sort of the stuff in your studio, the stuff where you're just making art. So I call it an art practice. I think it's very much like you're sort of looking and practicing and seeing and experimenting. I think they're all the same sort of family of actions or words. And then the data, well, the data is, the result. What are you getting? What are you looking at? So in the science world, you have your conclusion, and then maybe you analyze the data. Maybe you found that answer, right? Maybe you've answered your guess, your hypotheses, but maybe more often than not, it leads to another problem. So then you sort of start again, right? Or you refine. And then your hypothesis becomes just better. It becomes more educated. Right? Or maybe you did find an answer, and in the scientific community, you publish that answer, right? And there's a peer review. And the peer review, this is the thing I remember very clearly in science classes. Those tests, those experiments need to be repeatable, right? If they're not repeatable, then something is wrong with the procedure. Because they have to be objectively measured. So and the way to do that is to repeat it, okay? So as an aside, when I was looking at this and just kind of doing some literature research, I didn't realize how huge a problem that is nowadays with science. Because there's a lot of things published that people assume, oh, okay, it is true. Because maybe it has authority, like Aristotle saying, oh, it's true. It's in a respectable journal. But there's been some kind of meta-analysis and showing there's a lot of science out there that just hasn't been repeated and maybe is not very good. That's sort of an aside, but I think it's kind of interesting as a, I don't know, as a maybe a question mark to keep in mind about this process that we've been kind of told. All right, but so this is science one. I'm thinking, well, wow, everything about this is the artistic method, with maybe one exception, and that is that middle part. So if you found something and you want to show it, so if you, instead of publishing it, you exhibit it. So the same family of kind of verbs, you exhibit, you show it. And then you get the reviews, right? So the reviews, though, are from a peer group. They're from journals, respectable. There's a number of different journals, but a respectable journal would be great. But ultimately, what's the criteria there? It's not repeating the experiment. Like no one would ever think to repeat an artistic experiment, right? That's plagiarism. But there are other criteria, and maybe it's, I mean, it's subjective. It's very subjective, like, well, did that move me? Did that surprise me? Did that show me something that I otherwise hadn't seen? Did that, sort of take my breath away? The great things that art can do are these transcendental, and in a sense, really difficult to grasp things, but ultimately they're very subjective. It's about people's experience with the artwork. Okay? So that maybe is the only and biggest difference between scientific method and artistic method. All right. I was thinking about this also.